Hello friends, let's ready to enjoy third equation of motion, which is v square is equals to u square plus 2as, or you can also write v square minus u square equal to 2as. This is third equation of kinematics motion. This can be obtained by three methods. Method 1, algebraic method. Method 2, graphical method, and method 3, calculus method. Let us obtain this equation by these three methods followed by numerical on it. Let us see it. So we are going to start with method 1. So method 1 is your algebraic method. You know from first equation of motion. So we are writing here, we know from first equation of motion v equals to u plus at. This can be written as v minus u is equals to at. Let this be equation number 1. According to definition of average velocity, you have v average is equals to total displacement by total time taken. Let total displacement is s and total time taken is t. Then v average is v plus u upon 2. This is equation number 2. Now multiply equation 1 and 2. So multiplying equation 1 and 2, what you get? Let us multiply it. So you get v minus u on LHS side, v plus u by 2. So v plus u upon 2. And on RHS side, here 80, here s by t. So you have 80 into s upon t. This t will cancel out. And in LHS side, you have v square minus u square upon 2. On RHS side, you have as. Cross multiply 2, so you have v square minus u square equals to 2as. Thus you obtain third equation of motion algebraically. Now let us find it by the second method known as graphical method. So let us work out for graphical method. For graphical method, we required a VT graph. So here it is v, here you have t. So this is in second, this is meter per second. So the method is said to be graphical method. Let us have a uniform accelerated graph having initial velocity u. So the graph is this. This is a uniform accelerated graph having initial velocity u and final velocity is v. Let us drop this on time axis. Let us join it. So you have A, B, C, D, O. This is the naming of the graph. Now you know that this is VT graph. So displacement can be obtained by taking the area of this graph. So displacement is equals to area of VT graph. Now displacement is symbolized by S, and here area, this is a trapezium. So you can write area of VT graph means this, you have to find area of this shaded region. This shaded region is a trapezium. So this is area of trapezium. Name of trapezium is A, D, OB. So trapezium area is half sum of parallel side into perpendicular distance. So sum of parallel side, this means that BO plus AD. So BO and AD are parallel side, and this is the perpendicular distance OD. OD. What is this? Is half A plus B into H. This is said to be area of trapezium. This is the formula for area of trapezium which we have used here. Now here it is half BO. So BO is U. This is U distance. So right here U, and AO. Here we have AD. Sorry, here AD. D is here, AD. So AD is V. V is AD. This is AD. So here we have V, and OD is T. Now you know that we know V minus U equals to AT. So we have V minus U upon A is equals to T. So at the place of T, write V minus U by A. So therefore you have S is equals to half V plus U, and T is V minus U upon A. So 2A will be multiplied this side. You have 2A's on LHS side, and on RHS side we have V square minus U square. So V square minus U square. So this is the third equation of motion which we have obtained graphically. Now you are going to obtain third equation of motion using calculus. So the third method is known as calculus, by calculus method. You know that there is a word known as instantaneous acceleration. What is that? Instantaneous acceleration. What is the instantaneous acceleration? This is A is equals to dV upon dt. On the RHS side, we multiply numerator and denominator by dx. So it is dx upon dx into dV upon dt. Now shift this dt this side and this dx this side. So this can be written as dx upon dt into dV upon dx. This is A. So dx upon dt is instantaneous velocity v. You know that dx upon dt is equals to v. So at this place write v dv upon dx A. Cross multiply dx. So you have A dx is equals to v dv. Now integrate both sides with proper limit. So you have going to integrating both sides with proper limit. Let us integrate it. So you have sign of integration is here. A dx is equals to v dv. Sign of integration is here. So dv, when the velocity is initial, displacement is 0, and when the velocity is final, displacement is s. So take this a outside. So it is integration dx 0 to s. Here you have v dv u to v. Do not take v out because v is depending on dv. Now integrate this. So integration of dx is x. Give a bracket, square bracket, right here 0 and s. So lower limit is 0 here, upper limit is s. On the RHS side, integration of v is v square upon 2. Give a bracket, right here u and right here v. For more detail on integration and differentiation, must watch my video Basic Calculus used in Physics. So here you have a s minus 0, here you have v square minus u square by 2. So again you have 2as is equals to v square minus u square. Thus we get the third equation of motion using calculus. Let's see a very interesting numerical based on this third equation of motion. So here you have a numerical and see how to solve it. This is point A, this is point B. Let point A and B are 80 meter apart. Two cars are coming from A and B. From A, here this is UA with speed 72 km per hour, and this is a car UB with speed 54 km per hour. 54 km per hour. This is UB, this side. But in a foggy day, there is a foggy weather. There is a foggy day and 80 meter apart, two cars are approaching each other. Car A with a speed 72 km per hour, car B with a speed 54 km per hour. When they are at 80 meter apart, they see each other and they apply brake. And both apply brake apply brake with a constant retardation of 5 meter per second square. This means that both have a constant retardation is minus 5 meter per second square. This is A and this is also for B. Both have the same. Then the collision will occur or not. The question is, the two cars will collide or not. You have to give the answer. So for solving this problem, we are using the formula v square minus u square equals to 2as. Let us see the solution. So here for car A, you have v square A minus u square A is equals to 2a SA. So what is v square A? When the car will stop, then it will be 0. What is UA? UA is 72 km per hour. So UA is 72 into 5 by 18. So this is 420 meter per second. So right here 20 whole square, which is 2. What is A? A is minus 5. Right here minus 5 SA. So SA is, the square of 20 is 400. And 2 into 5 is 10 here. Minus sign will be on the same place. Cancel this. So this is 40 meter. When car A apply a brake with a constant retardation of 5 meter per second, it will stop after 40 meter. What about car B? Let's see. For car B, you have the formula v square B minus u square B is equals to 2absp. Here the speed of car B is 54 km per hour. So ub equals to 54 into 5 upon 18. This is 3, which is 15 meter per second. Therefore, this is B is 0 square minus 15 square is equals to 2 minus 5 into SB. So SB is, square of 15 is 225. So here you have 225 with a minus sign. 2 into 5 here, minus 10 is here. It is 22.5 meter. So distance covered by car B is 22.5 meter. Now the total distance total distance is equals to SA plus SB. What is SA? SA is from here 40. And what is SB? This is 22.5. So this is 262.5 meter. Since total distance 62.5 meter is less than 80 meter, so the car does not collide. Okay, and they were safe. Accident will be averted. Thus, you will learn third equation of motion in 3 methods and how to solve numerical based on this. Do like, share, subscribe my channel Physics Gold Ravi Kumar. Thank you.